Greetings, Physics 109 students. This video is going to talk about how to do problems 11, 12, and 13 on your Unit 3 homework, all right, about principles of work and energy. So in number 11 it says, let's see, a hydraulic pile driver uses a ram with a mass of 1,420 kilograms. The maximum energy is 1280 joules. How high must it be raised? So basically they've got this large object with a mass that's given in the problem. In my example, that mass is 1,420 kilograms, but yours that may vary. And the idea is, this mass gets lifted way above the ground to some height, and then it's dropped and used to like hit something and drive a stake into the ground or something. So it says if the maximum energy is 1280 joules, and again, in your example, this may be a different number, what height does it need to be raised to? So in this example, this energy, although it doesn't say it, it's a potential energy because they're talking about a height. And remember that potential energy is energy due to position. So the height is a position type of variable. So what we'll do here is we're going to write potential energy is equal to mgh, and then use whatever value you have here as your potential energy. The mass is given, g is 9.8 meter per second squared. Solve for h. That should be enough to get number 12 or 11 done. All right. Oh, there's a part B. So let's see. Assuming it takes 0.61 seconds to raise the ram, what is the power output? So again, my problem says 0.61. Yours may say a different number, but power is change in energy over change in time. So they're asking us to calculate the power. Whatever, when the ram is in this position, it doesn't have any potential energy. When it gets lifted to this position, whatever this number is, now is the potential energy. And that number is equal to the change in energy because it started at 0. So whatever value you get here, that was given in the problem. In my example, 12,280. This number is going to be this guy. And the power, and the time is given. Then you're going to just calculate the power. This is going to come out in joule per second, which is what a watt is. So this is going to be some number with units of watts. The next part of this where it says, what is the power in horsepower? That's a unit conversion. So the conversion factor to go back and forth between watts and horsepower is this. There's 746 watts. That's equal to 1 horsepower. So use this as a conversion factor. And again, if you don't remember how to convert units, go back to the first unit. I got some videos on unit conversions. Just treat this like a conversion factor. And that should be enough to get part 2 of number 11 done. All right, number 12. Let's see, a compact car can climb a hill in 11 seconds. So I'm going to clear this off here a little bit. Number 12 says something about a car climbing a hill. So I'm going to go ahead and put a car in my picture. And it's climbing a hill. Oops. So here, doggone it. Bear with me, I'll get this picture done. Alright, so this car is climbing a hill. And it says the top of the hill is 31 meters higher than the bottom. So, get a couple more pictures of this car. First of all, let's put our picture at the bottom of the hill. I'll fix that in a minute. Another picture at the top of the hill. And there's no actual hole in the hill. This doesn't have to be straight in this example. And in my example, it says that the top of the hill is 31 meters higher than the bottom. So in my example, this height difference here is 31 meters. Yours could be a different value, and that's okay. And I'm also given a time. In my example, it says 11 seconds. So that's a delta t. I'm going to write that down. Delta t, 11 seconds. And it says, what is the power output of the car? So power is change in energy over change in time. Or you can use work over time, because the work and the change in energy are the same. Work is the mechanism that changes your energy. In this example, the change in energy is a potential energy. So I'm going to put a datum right through the car right here. So we're going to say that the potential energy here is 0. The potential energy here is equal to mgh. Mass of the car is given in your problem. G is 9.8 meter per second, and the h is given in the problem. So calculate a number. Then take that number right here. That's going to be your change in energy divided by the time given. You're going to get a number. It's going to be a big number, and the units will be watts, or joule per second. This one doesn't ask to do the conversion, so I'll just leave it alone. So that should be enough for 12. Okay, 13 is about somebody running up 1,500 steps to a height of 1,050 feet. All right, so I'm going to get a new picture here. This is about a building, so if you'll humor me a moment here, I'm going to get my standard building I use for these types of questions. All right, and the idea here is that somebody ran up these stairs. Oops. Building's got some sort of ground there, okay. Now, who ran up it? Oh, if you'll humor me here. Use this young lad, Timmy, here, that I use for a lot of my videos. That's giant Timmy, I guess. We gotta shrink him down a little more here. Okay, good enough. So, the young lad starts here. He ends up here. Now, in this problem, they gave this height a couple of different ways. In my example, it says 1,575 steps. That's not really a step is not a physics unit. It says 1,050 feet, and then it also says, I thought I saw it somewhere. Guess that's all it says. Okay, that's fine. Okay, so this is not really a unit that we're worried about. The height difference is the one we're looking at. And the first question says, how much work did this Mr. Cake do to reach the top of the building? So if we write out a work energy theorem, PE1 plus KE1 plus work equals PE2 plus KE2. Now, why did I do that? Because the question said how much work was done, and I know that there's a work term in the work energy theorem. If we put a datum here, PE1 is 0. Now, this person, climbing up the stairs, he's not going to be moving very fast, and he's probably going to be going about the same speed all along through here. This problem just is not about changes in kinetic energy. These values here we're just going to throw away. They're not important for the problem. Even if they're not 0, they're probably the same, so they'll subtract off. So the work is equal to the PE2 term, mgh, where the mass is given, g is 9.8 meter per second squared. The only thing is we got a little bit of a glitch here. The height we are going to need in meters, because in part A, the units they're looking for are joule. So we're going to have to take this 1,050 feet and look up the conversion factor between feet and meters. And we're going to want to multiply by a conversion factor that has feet on the bottom, meters up top. It's about 3 feet per meter, but it's not exactly. It's like 3.1 or something. You're going to have to look that up. So look up that conversion factor between feet and meters, convert this to meters, this value will go here, and then you can calculate the potential energy, and that will come out in joules. Now, when you do the power, actually part A just says how much work done. So whatever number this is, you're done. That's the answer to part A. In part B, where it says what is his average power output in foot-pounds per second and horsepower, I would start with horsepower. Here's why. Once you have this change in potential energy, the power in watts is real easy to calculate. Remember, power is change in energy over change in time, or it's also equal to work over change in time. And here's why you can do that if you look right here. Because the work is equal to the PE2 term. So whether you're taking this and dividing by time or you're taking this and dividing by time doesn't matter because they're equal. So take these values and divide by the time given in seconds. You're going to get a number with units of watts now. Then you can answer the horsepower part because it says, let's see, power and horsepower. That's a unit conversion. There's 746 watts in 1 horsepower. So again, take your number with units of watts, use this as a conversion factor to convert the horsepower. The other question says in foot-pounds per second. So a foot-pound per second is another unit of power. There's a conversion factor between horsepower and foot-pounds per second, but I don't remember what it is. You're going to have to look that up. So figure out how many horsepower in a foot-pound per second. It's probably going to be, it might be 550 foot-pounds per second equals 1 horsepower. But again, look that up and verify. Use this as a conversion factor to convert your horsepower to foot-pounds per second. All right, and that should get that done. Again, if you have any trouble with these, please post in the forums. I'd like to see more questions posted possible because it gives me something to answer, and I'd like to see, I'd like for us to have as much interaction as possible. So I hope these videos help you get the homework done. Have a great day.